In this video, we're going to go over lesson 9.6, day 2. If you haven't already completed lesson 9.6, day 1, you should do that first. In day 1, we looked at two models of geometric probability, one involving length and one involving angle measure. In day 2, which is this video, we will look at the area model. So for example, let's suppose that I wanted to find the probability that if I randomly pick a point, that point is inside the triangle. The sample space would be all points in the rectangle, which is the big full figure. The event would be the point is inside the triangle, so all points inside the triangle. And then the probability that our random point is inside that triangle would be equal to the area of the triangle divided by the area of the rectangle. The area of the rectangle is the area of the total figure. So that's why that is in the denominator. That's our total. And the area of the triangle, that's where we want our point to be. In this example, we want to find the probability that a point chosen randomly inside the rectangle below is in each shape, and then we'll round the answer to the nearest hundredth. So let's start off with the circle. In order to find the probability that it's in the circle, we need the area of the circle divided by the total area, which is the area of the rectangle. So let's go ahead and start by finding those two areas that we need. For the rectangle, the area is base times height. That's our formula. And here, the base and height are 50 and 28. So we're going to take 50 times 28, which is equal to 1,400. Then I'm going to find the area of the circle. So for the circle, I'll do that right here, I guess. The area of a circle is A equals pi r squared, and the diameter of the circle is 18. Notice the 18 goes all the way across the circle. To get the radius, we just take the diameter and divide it by 2. So the radius would be equal to 9. Now we can go pi r squared, so that's pi times 9 squared. 9 squared is 81. So the area of the circle is 81 pi. Now we have everything we need to calculate the probability that it's in the circle. I'm going to go back to the formula that I wrote at the beginning. Area of the circle is equal to 81 pi. And the total area of the rectangle is 1,400. And I'll round my final answer at the end to the nearest hundredth. For now, when we type this in our calculator, we can just type 81 and then click the pi button. So 81 pi divided by 1,400, and the number that we are getting is 0.18176 ... So as a decimal, I could say it's about 0.18. But if I want to be a little more accurate, I could add some extra digits to it. So as a percentage, if we move it over 2 places, that would be 18 point, and then the 6 would round up, so 18.18%. Both of those are the same. They're just expressed differently. One is a decimal rounded to the hundredths place, while the other is a percent rounded to the hundredths place. For part B, we're going to use the same figure, but this time we want to find the probability that our randomly chosen point is inside the trapezoid. So the first thing I'm going to do is calculate the area of the trapezoid. Look at your formula sheet for the area of a trapezoid, and you'll see that it's A equals 1/2 B1 plus B2 times the height. The bases are the parallel sides, so B1 and B2 are 34 and 16. So I'm going to go half of 34 plus 16. And then the height is the distance between the bases, which is the same as the diameter of the circle right here. So that's going to be our height. 18. And now I'm just going to simplify that here. So it's half times 34 plus 16 is 50. And then times 18. And we can then just type that whole thing in our calculator. 0.5 times 50 times 18 is equal to 450. So the area of our trapezoid, 450. Now for our probability, the probability is just going to be the area of the trapezoid divided by the area of the rectangle. So we have 450 divided by 1,400. And if we type that into the calculator, the number that the calculator says is 0.321428. As a decimal, we could say that's approximately 0.32. And as a percentage, if I round to the hundredths place, that would be 32.14%. Here's a try now example. And in this try now example, it's the same exact diagram, but we want to find the probability that it's in one of the two squares. So that means that it can be in either of the squares. So for the area of a square, we know a square is just the same as a rectangle, base times height, or side squared, because it's a square. Both sides are the same, so both sides are 10. So I'm going to take 10 times 10, or 10 squared, and the area of a square is 100. For two squares, because I don't care which square it's in, the area is just going to be double that. So 2 times 100 is 200. And now we can calculate our probability. The probability is going to be equal to the area of the two squares divided by the area of the full rectangle. So let's take 200 divided by 1,400 and stick that into your calculator. And the number that comes out is 0.142857. So as a decimal, I could say it's about 0.14. And as a percentage, we move the decimal 2 places to the right. So 14.28. 5 makes it round up. So 14.29%. And this concludes lesson 9.6. Thanks for watching, and good luck as you solve some geometric probability problems.